Okay, we will go back to our graphs of sine and cosine waves now. However, this time we will be graphing with the angle measured in radians. We say that it is in terms of pi. So, for example, take a look here. You see pi over 2. Where when we graphed last day, we would have seen 90 degrees written here. In fact, every pi radians is equal to 180 degrees. And that's why pi over 2 is the same as 90 degrees. Okay, so we begin. The consideration is much like it was in our last class. So we write down the values of A and B and C respectively. But the one big change comes right here. In our last lesson, the period formula was 360 degrees divided by B. Well, in the numerator now, instead of 360 degrees, we will have 2 pi. 2 pi is the equivalent of 360 degrees. So this is our new formula. And so now we would substitute 3. And at this point, we would simply check, make sure that the fraction, in this case, it's 2 over 3. Just make sure that fraction is in lowest terms. And if it is, you stop here. Okay, now we'll do the phase shift calculation. And this formula is exactly as it was in our previous lesson. So it's the negative of C over B. In this case, then, it's the negative of pi over 2 divided by 3. Now, this is equal to negative pi over 6. So that corresponds to a phase shift of pi over 6 to the left. If you're not really great with fractions, you can use your fraction button to help you a lot in this particular lesson. The only thing is that when you use your fraction button, which is here, okay, on your if you have your Casio calculator, but you can find one on, I think, any scientific calculator. The key is you cannot put pi in your fraction. So this is the same as negative 1/2 times pi. Okay, so what you could do is in place of the pi, put a 1. So you could do this, negative 1 over 2. So that's the numerator, negative 1 over 2. And then divided by 3 equals, and you get negative 1 over 6. Just make sure that when you write your answer, this is negative 1 over 6 multiplied by pi. So it's negative pi over 6 that you write on your page. Okay, now we're going to come up with those critical points. So this is like what we did last day. We said, let's assume that there is no phase shift first. And if that was the case, the graph would start from 0 and it would end at 2 pi over 3. At least the first cycle would, right? It would go from 0 to 2 pi over 3. Then we're going to shift all of our values to the left. So I'm going to start writing my original values over here somewhere on the right side of the paper so that I can accommodate a shift to the left. Okay, so 0 to 2 pi over 3. And then remember what we did last day. We took this number and we divided it by 2. Now again, you can use your fraction button if you need to help you, except you can't put the pi in. So this is going to be treated like a fraction of 2 over 3. So let me just show you what I'm saying here. Okay, so we could do 2 over 3 divided by 2 is, of course, it's 1 over 3. So then you would write back 1 pi over 3. Okay. And now this number needs to be divided by 2 again. Divided by 2. And you get 1 over 6. Don't forget, multiply that by pi. So it's 1 pi over 6. And then remember how we always got this number here? We would simply add these two numbers together. So you want to add pi over 6 and pi over 3. So that's the same. If we're going to use the fraction button, we're going to add 1 over 6 with 1 over 3. So 1 over 6 is still in my calculator. So I'm going to do plus 1 over 3, and I get 1 over 2. So here I would write 1 pi over 2. Okay, so watch again. I'll do the whole thing again. So we have 2/3. Okay, I have to push equals so the calculator can see it, right? So now we have the 2/3. We would divide by 2, 1/3. Divide by 2 again, 1/6. And then take 1/6 and add 1/3 to it. And now we have 1/2. Okay, so that's just how to use your calculator to help you if you're not great with fractions. And now what I want to do, shifting to the left, so I actually want to take all of these numbers and subtract pi over 6 from them. So we're going to do 0 minus pi over 6 equals, and we're going to do pi over 6 minus pi over 6 equals pi over 3 minus pi over 6 equals pi over 2 minus pi over 6 equals, and 2 pi over 3 minus pi over 6 equals. So we're going to work those out. We did this exact same thing last time when it was in degrees. We would have been subtracting. Well, in this case, this is the same as 30 degrees. So we would be subtracting 30 degrees from all of our original values in this step. Okay, so the first couple here we can probably do without a calculator, I would think. 0 minus pi over 6 just is negative pi over 6. Pi over 6 minus pi over 6 is 0. And now you can choose if you want to do it manually or with the calculator. So if you want to do it manually, of course you need a common denominator. So this is 2 pi over 6 minus 1 pi over 6. So you will get pi over 6, right? This is 3 pi over 6 minus pi over 6, which is 2 pi over 6 or pi over 3. And this is 4 pi over 6 minus pi over 6, and that is 3 pi over 6 or pi over 2. So that's if you're good with fractions, and if not, you're going to do this. 1/3 minus 1/6 equals 1/3 minus 1/6 equals, and see what you get? 1/6. So then you write pi over 6. And then same thing, 1/2 minus 1/6 equals 1/3. So you can write pi over 3. And same thing here, 2/3 minus 1/6 equals, right? Okay, so however you need to, you get your guys, and these of course go on the horizontal axis, which we will label theta, okay, based on what's written here, versus y, like that. So these numbers go on the vertical axis. Now look, one of the critical points is 0, so that's right here. And then remember, I use 2 centimeters personally for my distance. So 2 centimeters this way. So that's where I'm going to write negative pi over 6. And then this will be where I write pi over 6, pi over 3, and pi over 2. Like that. Now look, we're only graphing the sine wave, okay? So take note, we are just graphing the sine wave. So how do we graph a sine wave? The first third and fifth points are on the axis. Okay, now I haven't even included these values yet. Remember the value of A was 1.5, so that means I need to show 1.5 and negative 1.5 on my vertical axis. So the second critical point is at 0, and the graph should be at its maximum then. Okay, this is positive, so the graph is going up first. So at pi over 3, the graph will be at its minimum. And then just do a smooth curve like this. There you go. That's one cycle of this graph. And we're going to practice this with a couple more examples. Okay, so here we go, example 2. Once again, it's a sine wave. Let's make note of A, B, and C. Remember, when C is written down, you must include the negative sign if it is negative. So we have negative 2 pi over 9 for C. Okay, let's make our two calculations. The first is for period. We know that when we see this in radians, we use this form of the period formula. So what is the period? It's 2 pi over 4. Now remember what I told you, you have to check to see that this fraction is reduced, and it isn't. 2 over 4 is the same as 1 over 2, so we get 1 pi over 2, or in other words, pi over 2. Okay, 2/4 is 1/2. Phase shift. Okay, negative C over B. So in this case, it's the negative of negative 2 pi over 9 divided by 4. Okay, so certainly we see that this will be positive overall. And we need to figure this out. 2/9 divided by 4. That's the same as 2 over 36, which is 1 over 18. So we get 1 pi over 18, or pi over 18. If you want to use your fraction button, you can. Okay, so we're doing 2/9 divided by 4. We know it's going to be positive. So 2/9 divided by 4. 2/9 divided by 4 is 1/18. So 1 pi over 18 is what we write on our page. Okay, see what happens when you try to put the pi in? 2 pi over 18. Sorry. Let me just try again. 2 pi over 9 divided by 4 is, see, doesn't work. Doesn't matter what I do. So that's why we can't put the pi in. We just have to do 2/9 divided by 4. Okay? Okay. Let's get our critical points set up. So first, let's assume no phase shift. I know I'm going to be shifting to the right, so I'm going to start writing my original guys here to the left of my page, just so I have space to shift to the right. So if there was no phase shift, the first point would be 0. This would be pi over 2, the fifth point. And then I have to say, what's pi over 2 divided by 2? Pi over 4. What's pi over 4 divided by 2? Pi over 8. What's pi over 8 plus pi over 4? That's 3 pi over 8. Okay, because it's pi over 8 plus 2 pi over 8, so it's 3 pi over 8. Okay, but again, you're welcome to do it on your calculator. Start with 1/2, right? That's what we're starting with, 1/2. Divide that by 2 to get your middle guy. See, right there. Okay, divide it by 2 again to get this one, and then take that 1/8 and add 1/4 to it, and you'll have this one. Okay? Now we're supposed to shift these all to the right. What does that mean? That means adding pi over 18. So I'm gonna write down what we're doing. We're taking each of these numbers and adding pi over 18. Okay, so the first one, certainly we can all do without our calculators. After there, it's a little tricky to come up with the answer because we need a common denominator for 8 and 18. Okay, so if you want to just cheat and use your calculators, it's 72 by the way. The lowest common denominator is 72, but just to show you in your calculator, you could just do 1/8 plus 1/18. Okay, so I'm gonna, wait, I'll just put it right there. 1/8, right? Plus 1/18 is, we get 13 pi over 72. And then we can do the next one, 1/4 plus 1/18, 11 pi over 36. 3/8 plus 1/18, 31 pi over 72. And the last one, 1/2 plus 1/18, 5 pi over 9. Okay, so again, calculator or no calculator. If you didn't want to use a calculator, then as I said, your common denominator has to be used. For example, this one here, in going to a denominator of 72, this would be 9 over 72 plus 4 over 72, and that's how we get 13 over 72. Or this last one, common denominator is 18. This is 9 over 18 plus 1 over 18, so it's 10 over 18, which reduces to 5/9, and so on. Okay, these are what we draw on our graph on the axis. So I'm gonna do the quick sketch. Oops, I went nice and crooked there for you. I'm sure you like that. Okay, quick sketch. So y, theta, the a value, take note because that tells us we need 5 and -5 here. And now all I need to do is write these 5 values to the right of 0. This is positive, so we know to start to the right of 0. So I'm going to say that that's the first one, and then every 2 centimeters. Okay, so those are my dashes there. So pi over 18, 13 pi over 72, and so on. Okay, now take note, sine wave. So first, third, fifth points on the line. The a value is negative, so this graph will be at its minimum first, and it won't be at its maximum until 31 pi over 72. Smooth curve. And that example is done. Okay, I think we'll do one last one together because I know that this can be a little challenging with all these fractions. Okay, so the last one you'll note is a cosine wave, but the whole process will be the same. A is 2, B is 8, C is positive 2 pi over 3. Remember, positive here means ultimately we'll be shifting to the left. Period, formula, 2 pi over B B is 8. 2/8 is the same as 1/4. And of course, your calculator will do that for you as well, right? 2/8, just push equals, right? 1/4. So this is 1 pi over 1 pi over 4, or pi over 4. Okay, that's a strange pi. Let me just fix it, sort of. And then phase shift. We take the negative of C over B. Well, I was going to write the formula first. Might as well. The formula, the negative of C over B. So it's the negative of 2 pi over 3 divided by 8. All right, and 2/3 divided by 8 is 2/24 or 1/12. So we get negative pi over 12. Okay, but just to show you, you can do negative 2/3. Just leave out the pi, divided by 8. Okay, so there it is, negative 1/12. And now we are all set. We're going to be shifting ultimately to the left. So I'm going to set up my original 5 points from the origin to pi over 4 first. Pi over 4 divided by 2 will be pi over 8. Pi over 8 divided by 2 will be pi over 16. Pi over 16 plus pi over 8 is the same as pi over 16 plus 2 pi over 16. So it's 3 pi over 16. And then we're going to be shifting all of those left. Okay, we can do that with the calculator. 1/4 divided by 2. There we go, 1/8. Divide by 2 again. 1/16. Take 1/16. Add 1/8, 3/16. Okay, now we take each of these and subtract. So we're going to do 0 minus pi over 12, pi over 16 minus pi over 12, and so on. Okay, so 0 minus pi over 12 will just be negative pi over 12. These other ones are a little tricky, so let's use the calculator maybe. So I want to do 1/16 minus 1/12. Negative 1/48, so negative pi over 48. 1/8 minus 1/12. 1/24. Pi over 24. 3/16 minus a 12th. 5 pi over 48. Lastly, 1/4 minus a 12th. This one's pretty straightforward. This is 3 pi over 12 minus 1 pi over 12. So it's 2 pi over 12 or pi over 6. Okay, but we could still do it this way. 1/4 minus a 12th. And we get a 1/6. So these are the numbers that will be graphed. Okay, I just wanted to show you really quickly, since we're obsessing over this fraction button, what would happen when you get, and I think I've showed you this before, but just in case, what would happen when you get a fraction bigger than 1? For example, let's say I was going to add 3/4 and 7/9. See, this is a mixed fraction. It means 1 and 19 over 36. So more than 1, right? 1 and 19 over 36. Okay, so if I wanted to write that instead as an improper fraction, I would just hit shift and hit this fraction button again, and it would change it for me immediately to 55 over 36. Okay, so again, mixed fraction, 1 and 19/36, or improper fraction, 55 over 36. That has nothing to do with this question, of course, but I just wanted to talk about the fraction button for another moment. All right, I'm gonna draw the graph. So we need a horizontal axis labeled theta. We need a vertical axis labeled y. I've got 2 negative numbers. That's why I put my vertical axis here, because I'm gonna have 2 guys to the left and 3 to the right. Anyway, on the vertical axis, the number I need is 2. So let's just say that that's 2. And down here, that's -2. And now, yeah, we're gonna need 2 values to the left of 0, right? There's 2 negative values. So I'm gonna say that that's 1. And now I have to make everything, now that I've indicated that spot, this should be 2 centimeters. Here, 2, 2, 2. So my spacing from here to here equals the spacing from here to here, and so on. Okay, so this is -pi over 12. This one is -pi over 48. Then we have pi over 24, 5 pi over 48, and pi over 6. Okay, and then we're gonna draw the waveform. This is cosine. So at the 2nd and the 4th points, we will have heights of 0. The A value is positive. So at the 1st point, it will be up at +2. Like this. It's coming down. It'll hit the minimum right here. At pi over 24, we'll be down to -2, back through 0, and back to the maximum of 2 at pi over 6. And then just smooth wave. Okay, extend beyond a little bit, right? To show, yeah, I know this is a cycle. It goes on and on and on. All right, so that's 3 examples, graphing sine and cosine waves in radians in terms of pi. I have recommended some problems for you to try from your textbooks. Okay, thank you. Have a good day.